Shall we read 417? Why
Um,
don't you start it?
of two sets of 60 closest packed spheres, two identical sets of 60 spheres in closest packing precess in 90-degree action to form a 7-frequency, 8-ball to the edge tetrahedron with a total of 120 spheres. Exactly 100 spheres are on the outer shell, exactly 20 spheres in the inner shell, and there is no sphere in the nucleus. The largest possible double-shelled tetrahedral aggregation of closest packed spheres having no nuclear sphere. As long as it has as the 20 sphere tetrahedron of the inner shell, it will never acquire a nucleus at any frequency. Precession of two sets of 60 closest packed spheres as 7-frequency tetrahedron. Two identical sets of 60 spheres in closest packing precess in 90-degree action to form a 7-frequency, 8-ball edged tetrahedron with a total of 120 spheres, of which exactly 100 spheres are on the surface of the tetrahedron and 20 are inside, but have no geometrical space accommodation for equal radius nuclear sphere. The 120 sphere non-nucleated tetrahedron is the largest possible double-shelled tetrahedral aggregation of close packed spheres having no nuclear sphere. Try to say that 10 times
Here's,
fast.
yeah, and here's the result. So there's no nucleus in this. We'll take his word for it, and you can see how these two join.
The 120 spheres of this non-nuclear tetrahedron correspond to the 120 basic triangles that describe unity on a sphere. They correspond to the 120 identical right spherical triangles that result from symmetrical subdividing of the 20 identical equilateral and equiangular triangles of either of the spherical or planar faceted icosahedron accomplished by the most economical connectors of the icosahedron's 12 vertexes to the mid edges of the opposite edge of their respective triangles. Which connectors are inherently perpendicular to the edges and pass through one another at equitriangles center and divide each of the equilaterals into 6 similar right triangles. These 120 triangles constitute the highest common multiple of system surface division by a single module unit area, as these 30-degree, 60-degree, 90-degree triangles are not further divisible into identical parts.
So this is really a mouthful and it's scary, but I would propose that you kind of work your way from the center outward. The icosahedron is the key here. What Fuller's saying is when you take the icosahedron, which looks like this, these are good drawings, and then you kind of sphericalize it. So you put it on a sphere. So you've got 20 triangles. You can imagine, you know what, I can just say spherical. You can imagine, I think, without breaking your brain, that it would be rounded. See that these are more rounded. And then he proposes an operation where you cut this way and cut and you add lines. And I do think it's really interesting. I haven't double checked it, but going back to where you were, just one moment, he's connecting. So you got 20, the icosahedron has 20 triangles, and you put it on a sphere, and then you do this dropping these lines, so each one of them ends up becoming 10. So it's some kind of subdivision like this, where each one of the 20 becomes 10. But if you cut this triangle into one, then here you get three. And remember, the 10 is a triangular number, so each one has 10, and overall you get 120 triangles. But Fuller in this section is saying the reason why he focused on this tetrahedron with 120 is because it relates to Fuller's mind to the 120 of that subdivision. Okay, you want to take us to the
Yep.
end?
When we first look at the two unprecessed 60 ball halves of the 120 sphere tetrahedron, our eyes tend to be deceived. We tend to look at them three-dimensionally, i.e., it asked in the terms of exclusively rectilinear and perpendicular symmetry of potential associability and closure upon one another. Thus, we do not immediately see how we could bring two oblong quad quadrangular facets together with their long axes crossing one another at right angles. Our sense of exclusively perpendicular approach to one another precludes our recognition that in 60-degree versus 90-degree coordination, these two sets precess in 60-degree angular convergence and not in parallel edge congruence. This 60-degree convergence and divergence of mass-attracted associabilities is characteristic of the four-dimensional system.
So then, if I may annotate, we've got a difficult one here. I'm not sure we want to tackle it fully. But what Fuller's saying is, okay, team, I walked you through this, and these two align perpendicularly. This guy is perpendicular to this, seems to be perpendicular. This is across, and this is up, and I made a tetrahedron. Now that I've done that, I want you to know it's not perpendicular. It's a 60-degree coordination because it's not actually uh, straight up and across as I'm doing for the camera here. It's leaning. They're leaning on each other. And so Fuller wants to make sure that we understand that. I'd say that's a beginning to understand more clearly these two paragraphs.
Well, just for me, it really helps to try and put together that fuller, no pun intended, but understanding precession in terms of the vertical axis and the horizontal axis, uh, creating motion that's perpendicular to the actual axis. But now we're also saying that it really isn't perpendicular, it's angular, 60-degree angular connections. Is that correct? Is that what I'm
I think
getting
so,
out of this?
Richard, because that's what he says here, point blank. Says our sense of perpendicularity, because we're trained in it, we're used to it. Our homes have perpendicular
Yeah.
walls. So Fuller wants to say right out in this section, these are precessing in 60 degree. And that is characteristic of four dimensional.
It's one of those things that's always puzzled me too when he talks about precession happening at right angles, because when you're like looking at the orbit as an example, it's fairly clear that it's not at right angles, right? I mean, I guess at the satellite position to a certain extent, if you reduce to just the tiniest of vectors, yes, I guess perhaps it is. That the falling in, is an XC, the gravity, and then the flying away, right, at the instant is at right angles. Um, but the resultant is not. Maybe I should start making diagrams that just zoom into that tiniest little spot, and it would help me figure it out. So anyway, I like the 60-degree commentary here because somehow intuitively that means I can look at that some more and maybe I'll get it.
I just wanted to bring up there's that, I can't remember the name of the book, but I think Kurt, you were gifted the book at one point, right? That big spheres book. That's a good one to sometimes reference when you're going through all this Bucky stuff as well.
Yeah,
Difficult book, but everything's in it. It's really remarkable. And
yeah.
Popko is very Fuller influenced.